Hello students. So we were doing relations and functions. Okay. So today we are going to learn about invertible functions. Okay. So it's like we have to prove first it is 1 1 and on 2, that is bijective. Okay. Then only the inverse exists. Okay. So the definition is function invertible functions. Okay. So the function is defined from x to y, is defined to be invertible if there exists a function g from y to x, that is back to that, okay, such that g composite f is equal to identity of x and f composite g is identity of y. Okay, that is when you are taking g composite f of x, you should get x, and when you are taking f composite g of x, that time this will be y. Okay, should get y. G composite f of x should get x, and f composite y should get y. Okay, the function g is called the inverse of f and is denoted by f inverse. So g becomes the inverse of f and denoted by f inverse. Okay, let's see one example given in the textbook. So let f from set of natural numbers to y be a function defined as f of x is equal to 4x plus 3. Okay, and y is given to be y belonging to n such that y is equal to 4x plus 3 for some x belonging to set of natural numbers. Show that f is invertible and find the inverse. So first you have to find out g composite f and f composite g, right? So here y is given to be 4x plus 3. So this becomes your g, this is f of x equal to 4x plus 3. So first you have to find g of y. Okay. So g function is given from y to n, right? So put f of x equal to y. So this is 4x plus 3 equal to y. So this is y minus 3. So x is y minus 3 upon 4. So this is your g of y. So g of y is given by y minus 3 upon 4. Okay. So now you have both the functions f of x and g of y. So first you find out g composite f of x. So this is g of f of x. F of x is 4x plus 3. Then you have to put this as y here. So 4x plus 3 minus 3 upon 4. So we'll get x. So we are getting g of f of x to be x. Okay, one way it is proved. Another is f composite g of y. G of y minus 3 upon 4. So 4, here you have to put this 4 plus 3. 4 gets cancelled. Y minus 3 plus 3. So you get y. Okay, so this is also proved. So we can say that f is invertible and g is the inverse of f. Okay. Next question. Let y the set of n square n belonging to set of natural numbers. Function is from n to y given by f of n equal to n square. Show that f is invertible. First you write down what is g. G is from y to n. Okay. Now this you have to put equal to y. So n square equal to y. So n is root of y. So this becomes your g of y. Okay, you can take your root of n, it will be right, root of y. Okay, so I'll start with g composite f of, in place of x we are putting n, right? Of n, this is n square. So in place of y you have to put this. Okay, so okay, f composite g of y, g of y, so root of y, this is y square, which is y, and this is n. So when we are putting this n, we are getting n. For y, you are getting y. So this is invertible. Okay, so f inverse is g. Next question. Let f from set of natural numbers to real numbers be a function defined as f of x is equal to 4x square plus 12x plus 15. Okay. Show that f from n to s, where s is the range of f. Okay, where s is the range of f. Range of f means all the mapped elements of f. Okay, find the inverse of f. You have to find inverse of f. Okay. So I'll take this as f of x is equal to some y. Okay. 4x square plus 12x plus 15 is equal to y. So we can write this as 4x square Okay, I'll write this 4x x plus 3 y minus 15. How to find x, right? So you can take 4x square plus 12x. You have to split this, means you have to write it in terms of a plus b the whole square type. Okay, so this is 4x square plus 12x plus 15 is equal to y. So 15 you have to discard. Just see these two numbers. We want a plus b the whole square, right? Which is a square plus 2ab plus b square. So we have here a square which is 4x square, and your 12x is 2ab, right? So you have to find b. So 2ab is your 12x, okay, where 2x becomes your a. Okay, so b is 12x upon 2 into 2x. So this is 3. b is your 3. So you can write this as 2x plus 3 the whole square. Okay, I'll write again. Splitting you have to do 4x square plus 12x. 3 square you have to write, which is 9. And you have to just add and subtract. Okay. And this becomes your extra number, right? So you should get 15 here. So adding 15 you should get, right? 6. 9 plus 6. This 15 you can split. Like this you can write. Okay. So this becomes 2x plus 3 the whole square plus 6 equal to y. Okay. So your x is y minus 6 root of y minus 6. 3 you have to take that side, so minus 3 and 2 divided by 2. Okay. So this is your x. Now you have to take from range to set of natural numbers, and this is your g of y. G of y is root of y minus 6 upon 2. Okay, now you have to check for g of f of x and f of g of y. Okay, this is little bit lengthy. So this you have to put here. So we can make use of that. This becomes your 2x plus 3 the whole square, right? So 2x plus 3 minus 3 upon 2. So you are getting x. Okay. So this is equal to x, and other one also you will get as y. Okay. Let's move on to, so that is invertible function. Next question is consider function from set of natural numbers to set of natural numbers. G is also from same, and h is from n to r. Okay, defined as f of x 2x, g of y 3y plus 4, and h of z as sin z. Okay, you have to show that h composite g of f is equal to h composite g of composite of f. So consider first LHS x. Okay, h of g of f of x. f of x is 2 of x. Then this 2x you have to put here. Then you have to put this in each of z. Okay. Next is your RHS. And that you have to write H composite G of composite of f. Okay. Of x. So H composite G of. So this will be again the same thing. 2x. Same it is. Okay, you are getting the same it will be. Okay.